Hello students, I welcome you all to EPG Pathshala program. I am Dr. Aditya Tripathi. I am Assistant Professor at Banaras Hindu University. I will be talking with you about semantic web and its architecture and promises what semantic web offers to all of us. In this module, the first thing we would like to talk about is semantic web. What it is. There are several different definitions to semantic web. The very first definition of semantic web is that it is a web of applicationable information where information derived from data through a semantic theory for interpreting the symbols. Basically, what this definition tells us is that semantic web is a phenomena where the information available on web becomes some kind of dynamic information, and it can be used for drawing inferences and doing certain kind of machine computation. The second definition says that it is a concept which makes possible to organize available web information resources and to use them not only by syntax and structural methods but also by the semantics. Then the third definition, which is given by Tim Berners-Lee, who has actually given the idea of semantic web. What he says is semantic web is an extension of current web in which information is given well-defined meaning, better enabling computers and people to work in cooperation. What he says actually is it is an extension of the current web, the present web, which we are using so far. Only thing what he says is here the information available on web becomes meaningful to the machines, and then people can use this information through computers, and computers become a kind of agents to offer services to the people. Then another definition, it says that we can define semantic web as the web which can provide search results a semantic meaning. Search engines can understand the meaning of searched linguistic elements, that is terms, by analyzing it and show the results in defined way. Basically, this definition says that the machine or the computers or the search engines will understand the meaning of the search term under various contexts, and they will generate the services by analyzing these terms under different contexts. Then need of semantic web. Basically, there different web objects are there on the web, and these web objects or web documents may be represented in different ways semantically based on the context. Building a system where machine analyzes such terms and understands its meaning and interprets accordingly. The idea behind semantic web is that machine should understand the meaning of the terms, meaning of search results under different contexts, and derive inferences out of it, so that machine can automatically draw inferences and the data can be used for the generating services. Coming to the concept of web, the present web, which is the web of data and web of data or the objects, web objects. Here the basic goal is to provide a common framework to share data across various web applications across the boundaries. Okay, so the idea is that the data or the web objects, one web object can be inferred under various contexts, and different services can be drawn from one object. And the idea of building semantic web is based on ontologies, then standards, and there are different layers to it. Coming to history of semantic web. Web was invented by Tim Berners-Lee with some other fellows. Basically, he was physicist working in CERN's lab, Tim Berners-Lee has originally visioned the web and was much more ambitious than the reality of existing syntactic web. Tim Berners-Lee have since been working towards realizing this vision, which has become known as the semantic web. This is the architecture of semantic web over which the whole model is built. Basically, there are different layers of semantic web starting from bottom to top. In the next few sections, we will be talking about different layers of semantic web. The first layer from the bottom is URI layer. URI stands for Uniform Resource Identifier. The basic idea is that each resource on the web has a unique ID by which it is identified. So basically, URIs are the ground term for semantic web. The most important use of URI is that it provides understandable identification of all resources in a distributed internet system. And next layer is XML layer. XML stands for Extensible Markup Language. Basically, this language is a user definable language and domain specific language. It is used for those documents which have structured information, and XML namespaces allow to specify different markup vocabularies in one XML document. So basically, with namespaces we can use different metadata schemas or vocabularies in one XML document by calling them using namespace. Extensible markup language was designed to describe data. XML tags are not predefined in XML. One can define his or her own tags in XML document. XML uses a document type definition to describe the data. This is basically to authenticate the structure of XML document. XML with a DTT is designed to be self-descriptive. It shall be easy to write programs using XML. The processor could read the XML document easily. XML document is human legible and reasonably clear. The XML design should be prepared quickly. The design of XML should be formal and concise. XML document shall be easy to create. Basically, XML document is a plain text file. Here is one example of an XML document. You can see here that the first line demonstrates that what version we are using of XML, and in that there is a property called encoding, which says that it is UTF-8 document, which is a character representation system. From the second line, actually it is, this document is, if you read this document, it is about a book. In the second line, there is a tag called book, which is started. Inside this book tag, there is another tag called title, which has a value called prolegomena to library classification. Then inside book, there is another tag called author. Inside author, there are two tags called F name and L name, representing first name and last name of an author. Then inside book, there is edition tag and place tag, publisher, and so on. So if one sees an XML document, this one XML document displays a hierarchy of tags in which there are parent tags and child tags. The next layer is RDF layer. RDF stands for Resource Description Framework. It is basically a conceptual model of representation of knowledge within the document. This RDF standard is maintained by W3C. Basically, an RDF statement is represented by a triple. We also call it as expression or statement. A triple has three parts: a subject, which is represented by a resource; a predicate, which is the property of the resource; and object, the value of resource. In this slide, we represent a RDF statement. in this statement, one can see that there is a resource called isibank.ac.in/drtc. Then there is a property to this resource called as creator, and the value to creator is Suchitra. The domain isibank.ac.in/drtc is subject, creator is product, and value is object. This is a little complex model of RDF representation. Here the same resource is represented by many properties. In order to represent the properties, we have used Dublin core. That is why here you can see that we have used Dublin core namespace. There are different properties for this resource, like Dublin core creator, Dublin core contributor, Dublin core title, rights, Dublin core data, Dublin core language, Dublin core format, identifier, and so on, and then the values to these properties. This is an RDF representation of a document. Previously we have shown. In an RDF document, which is an XML file, we have very first element called as RDF, and then the whole document is represented by RDF description. Inside RDF description, we can use namespaces, like in our case we have used Dublin core elements like title, creator, language, and so on. Then the next layer is taxonomies and ontologies. Both terms are synonymous terms and almost used in same context. Ontologies may include many taxonomies. RDF schema is used to develop taxonomies. So an ontology is basically like a map, concept map, and in one concept map there can be many taxonomies. This is an example of a taxonomy where the very first class is Animalia. Animalia class has two subclasses called Chordata and non-Chordata. Chordata class has Protozoa, Coelenterata, Porifera, and so on, whereas Chordata has species, amphibia, reptile, aves, mammalia, and so on. This is actually an example of taxonomy of animal kingdom. Coming to ontologies, ontology studies existence of entities and their relationship. Basically, in ontologies, there are concepts, there are objects, and it is the study of these concepts and objects in relation with other objects in the real world. Ontologies are basically these are groups which are formed due to likeness or similarities of characteristics or attributes of individual entities. In ontologies, relationship is depicted in form of hierarchy and subdivisions. Conceptualization of world based on entities and their mutual existence are depicted in ontologies. This is an example of ontology of subject fine arts, where different facets of fine arts are depicted in this ontology. Ontology layer is nothing but it is a shared conceptualization. It uses RDF to represent the knowledge of the document or the subject domain. It uses a language called Web Ontology language. It is a standard language used to design ontologies. A role of ontologies. Individual web page or objects can be considered as an entity and will have its attributes and characteristics. The pages and objects can be grouped, and further they can form relation with other web pages or objects or groups of web pages. This is ultimately they make a kind of web ontology. This framework uses standard vocabularies like resource description framework schema and web ontology language for describing the concepts and its relationship with other concepts. Web ontology language, or we commonly call it as OWL, is another effort developed by the OWL working group of World Wide Web Consortium. Actually, it has three flavors. The first one is called OWL Full, then second one is OWL DL, and the third one is OWL Lite. OWL Lite provides many of the facilities of DML plus OIL provides. In addition to RDF, RDFS tags, it also allows us to express equivalence, identity, difference, inverse, and transitivity. Actually, OWL Lite, using OWL Lite, one can design his or her own ontology in addition to using RDF tags. Actually, OWL Life is a subset of OWL DL, which in turn is a subset of OWL Full. So, if one likes to use full strength of OWL, he needs to use OWL Full. Then comes RIF. RIF stands for Rule Interchange Format. It is used for creating rules so that inferences can be drawn and data can be exchanged and understood across different ontologies. It works primarily with rule layer. It is still being evolved and maintained by W3C. Next one is SWRL, which is Semantic Web Rule Language. It is which is a proposed language for semantic web that can be used to express rules as well as logic, combining OWL DL or OWL Lite with a subset of rule markup language. This is also maintained by W3C. Basically, RIF and SWRL together forms a language. Using both the languages, we can infer the knowledge domain and then draw the inferences. The next one is Sparkle. Actually, it is a query language. Sparkle stands for Sparkle Protocol and RDF query language. Query language, it is query language to retrieve and manipulate data stored in resource description framework format. So basically, Sparkle is used to query any RDF document. The next layer is proof or rules layer. Rules are used to perform inference over ontologies. So rules basically infer an ontology and draws conclusion over which some services or some decisions are made. These rules are also used as a tool to capture further knowledge. The proof layer is for approval of the various inputs and processing. Next layer is trust layer. It is the top layer in the semantic stack. It should support for provenance or trust. Provenance basically means where does the document come from, how does the information has been obtained, and can I trust a piece of information. Trust is largely unexplored issue. There is no standardization effort so far towards developing trust layer. In trust layer, there are several policies which can be adopted, which can be used. The first one is reputation based trust, which includes rating system, which is normally used in our today's search engines to rate the web pages. The second one is context based trust, which uses lot of background information to build trust. Then the third one is content based trust. Basically, in content based trust is lot of related information content are analyzed, and in the context of these information, the trust for the present object is built. Coming to promises of semantic web, semantic web can represent information in more categorized way, unlike our present day search engines or present day web, where information is disorganized. Taxonomy is more standardized way for representing knowledge. In semantic web, we use taxonomies, which is more standardized way to group same kind of information, same kind of object at one place. Data can be linked such that meaning of full inferences are drawn. The whole concept of semantic web would function over web browser. One need not to look for new software and technologies. new mechanism to find more reliable and trusted information. In fact, in the present web, we have lot of information. When we perform a search, we get lot of junk information. However, while using semantic web, one get the information which are meaningful for based on the context set by the user. The last one is new services and agents will be developed based on such kind of semantic technology, and intelligent agents will be used to pipe in useful data from other resources. Dear students, so far we have discussed about semantic web, what it is and the need of it. In the present module, we have discussed about the architecture of semantic web, and it promises this technology is still to be evolved and much more has to be done. The standards are still being evolved by W3C, like OWL and RIF and SQ, Sparkle and so on. For much more detail, if you are interested in, you can look into eText. Thank you.